It says a regular playground is to be fenced off and divided in two by another fence parallel to one side of the playground. 400 feet of fencing is used. Find the dimensions of the playground that maximize the total enclosure. So the first step is always to name your variables. So what do they want us to find? The dimension. So let's let I would use W. W is obviously the width and L is the length.
Okay.
So let's use W and L.
No, can we keep it X and Y?
Let's make it X and L, because that way we don't have to. The first step is always to name your variables. So when we name our variables width and length, that usually is a little bit easier. Okay, it's to be fenced off, divided in two by another fence parallel to one side of the playground. So 400 total feet of fencing is used. So the first thing we have to do is figure out how many, is all of this fence or is just some of it fence? That's the first question. Is that entire thing going to be fencing, or is some of it, is some of the fence already existing? Notice it says another fence parallel to one side of the playground.
A rectangular playground is to be fenced off. No, it all has to be fenced, right?
Yeah.
It says divided in two by another fence parallel to one side. Okay, so yeah, so all of this is fencing that we need. There's no existing
there's no
fencing.
fence.
So how many total W's do we have? We have three W's, and we have two L's. That's our perimeter. This is called our perimeter equation. And the total perimeter is 400.
We can use a note card on the quit. Oh.
Now it says that find the dimensions of the playground that maximize the total enclosed area. So here's our area right here. Our area equation is X times Y. So here's our one.
What about,
equation.
I thought it was W and L.
Thank you. You were using X and Y, and I switched to W and L. You're right. Thank you. W and L.
Dwy.
Good job, Ashley.
I try. I gotta keep Dwy in line.
Good job. Way to go. All right, so we got 3W plus 2L is 400. Notice that's one way that W and L are related to each other. And the other way W and L are related is in our area equation. And what we want to do now is solve this equation for one of them. It doesn't matter which one. And then plug it into that equation.
So we just set 1 equal
We
to
want to
0.
write the area in terms of just W or L.
Okay.
Doesn't matter which one we do. Let's do it in terms of W. We want the area in terms of W. So we're going to solve this for L. I'm going to do this in my head. L equals 400 minus 3W all divided by 2. I just got rid of the 3W first, and then I got rid of the 2. And now that I have done that, I'll change colors to red. Now I can take this equation,
Stop.
and instead of L,
I'm trying to keep up with you.
I'm going to write.
Can you pause this or something?
Alright, so when I plug this in, and you could simplify this, by the way, into 200 minus 3 halves W. Distribute the 2 into both of those. So it's going to be W times 200 minus 3 halves W, which I could now, of course, distribute the W in there. And so I would get, let's write this in standard form too. 3 halves W squared, negative 3 halves W squared plus 200W. That's my formula for the area in terms of the width. Now this right here is an upside down parabola because it's a negative leading coefficient of a quadratic equation. So this point right here is the point where it's going to maximize the W. Your W is going to be maximum at that point, and if you remember the trick to finding that point, that's called the vertex, and that vertex is negative b over 2a, comma, whatever the y value would be. Now that y value is your area. That's your x. That's your width. That's your that's the width that gives you the maximum area. So not only you have to find negative b over 2a.
Is maximum area the one that you write, like, no, the dimension's the one you write by 50 by 100?
Yeah, you look at the directions. Let's go back
So
up
do you
here.
multiply the dimensions by each other to get max area?
Yep. Nope, you don't need to multiply because you're gonna have this formula right here.
Yeah.
So all you have to
you
do
just
is
plug
plug
one
it
in,
in.
duh.
So what's negative b? Negative 200 all over 2a, which is negative 3/2. These 2's cancel. It's going to be positive 200 over 3.
What 2's? Oh, there's a 2 in front of it.
The 2 and the negative 3/2. So it's going to be positive 200 over 3. That's your maximum width. Your maximum width is 200 thirds. Plug in 200 thirds into here and into here. Don't round it. Don't write it as a decimal yet, because then you'll have to round it a little bit, because 3 doesn't go perfectly into 200. Plug it into here and here. Use your calculator and find out what your area is. The area of 200 thirds is what? So your answer is going to be, when you plug it in, 6666. Ooh, this is a devilish problem. 0.7 roughly. That's your maximum area for the total enclosed. And let's make sure we answered it. What is the maximum area? Oh, look, it also said find the dimensions of the playground. So we need more.
Of course they do.
We need to find L now. What's L?
So wait, can't we we found W.
So here's your max
wait.
area. And where's
Can
your...
So isn't this W?
Yep. Found W, which is 200 thirds. Why don't we just plug 200 thirds into here? Hey, look, we can do that. And the 3's will cancel
Wait, into this one?
into the original
Top
equation.
one? Okay.
The 3's will cancel.
Or I'll just do it on my... Can I just do it on my calculator?
Or you could just also plug it into here. Either one, because you know the area. But this is the easiest one. Let's just do it in our head. It's going to be... Now I'm going to subtract 200, so it's going to be 200 equals 2L. So what's L going to be? 100. So our dimensions are 200 thirds by 100. And your area is 6,666.7.
When I divided, I simplified, right? There was a 9 out front, so I simplified the top.
Wait, what is like a GCO?